Okay, so let's look at a very, very elegant proof of why this identity is true. And I'm going to use a unit circle to help me out here. In fact, let me just make that diagram a little bit smaller. I'm going to use 2 unit circles to help me out here. So I think you guys will like this. I don't take credit for this idea. I saw it online, but I haven't seen it in a lot of places. So this might be news to a lot of people. The proof given of this identity in Wikipedia is very long. It involves drawing 2 right-angled triangles on top of each other. It's quite messy. And I like this one, personally. So what we're going to have is I'm going to draw the same triangle here and here. Okay, and let me use different colors for this to be super clear. So I'm gonna have what'll I pick? Let's use this burgundy kind of color. Okay, so this angle is beta, and this angle will be my alpha. Okay, and therefore this angle is my beta, and this angle is my alpha. And the crux of this proof will basically be that the line here, let's call it L, this line L and this line L have the same length, right? Remember, this is a unit circle, so remember the circular definition of sine and cos, not logically circular, but just like drawing on a unit circle. You can know this point, the coordinates exactly. Right, this is a unit circle, so the coordinates of this point are just 1, 0. Over here, it's just going to be cos of alpha plus beta. Right? Sine of alpha plus beta. Writing's a little messy there to fit it all in. And let me write the coordinates of this guy in green. Well, this is just going to be cos of beta, sine of beta. And down here, this is going to be cos of alpha and minus sine of alpha. Okay, so the crux of the idea is that this line L is the same length. So let's use coordinate geometry to, okay, well, first of all, if L has the same length, then L squared has the same length, right? By coordinate geometry, let's use, let's calculate the length in this picture on the left. So the difference between the x coordinates, that's going to be cos of alpha plus beta minus 1. So that's the difference in x squared, and then the difference in y squared, because one of the coordinates is 0. This is just going to be sine squared of alpha plus beta. Okay, so this is L squared by this picture. Okay, just doing coordinate distance. Okay, now let's expand that out a bit. What I'm going to have is cos squared alpha plus beta minus 2 cos of alpha plus beta, just expanding that squared bracket there, plus 1, and then plus sine squared. So this comes from the end. Now what do we do? Well, notice these two guys here, they will add to give 1, because I know that cos squared plus sine squared is 1. So this means that the left-hand side here, or the L squared from the left picture, I can write as this. So 2 minus 2 cos of alpha plus beta. So keep that in mind. Now we're going to do the same thing on the second picture over here. So now I will write what is L here. So L is going to be the difference in x squared. So let's see, L squared. It's going to be, this is going to be cos beta minus cos alpha squared. Okay, so that's the difference in x plus the difference in y. That's sine beta plus sine alpha squared. Okay, and this is going to be, so let me expand that out and use a different color. This is going to be cos squared beta minus 2 cos beta cos alpha. plus cos squared alpha plus sine squared beta. So doing the same thing with that. And this time this will be a plus instead of a minus 2. Sine alpha sine beta plus sine squared alpha. Now, some of these terms group together quite nicely. So the sine squared beta and the cos squared beta, add those, you'll get 1. If you add the cos squared alpha, the sine squared alpha, you'll also get 1. So 2 1s are 2. So this becomes 2, okay? And then this will be, let's go minus 2. I'll take that outside. And I have a cos alpha cos beta minus sine alpha sine beta. Okay, so that's what I can write that as. So that's L squared using the right picture. Now look at this term, and then going back to what we did, look at that term there. Okay, if these guys are the same, then this just gives me an expression for cos of alpha plus beta, right? I've calculated L squared in 2 different ways, but looking at the result, this can only make sense. This can only be mathematically consistent if the blue items that I've underlined there are equal to each other. So in fact, we deduce the identity as required. So that's pretty cool. Okay, so we've proved it for cos. How do we do it for sine? So you just do the same thing. I'll let you guys try it yourself. I wouldn't want to spoil it for you because it's quite a nice exercise to work through, very satisfying. I sat in my college today and on a wall and just like tried to work this out for a while before my friend came over and he helped me, and we got to the answer together. So it's considering you basically, well, I'll give you a hint. You want to add another 90 degrees here to this angle, and then you want to consider this line here. So let's call it L2, and do the same thing that we did, right? So this is a point here, and again you want to consider that distance there, right? So this green line on both pictures is going to be the same now, okay? And you're going to basically work out the L2 squared in both pictures and compare and get the result. Now the trick is that when you write down these coordinates over here, because I've added 90 degrees, okay, so now we're all the way over here. So keep the picture in mind. I will write down the coordinates of L2 down here where I have some room, because I've gone basically alpha plus beta plus 90. The coordinates are going to be cos of alpha plus beta. Keep saying 90 instead of pi over 2. It's a bad habit. So these are going to be the coordinates of that point. Alpha plus beta plus pi over 2. But by the previous video, what you want to do is you want to use the identities that we talked about. Right, so we said that cos of something plus pi over 2, that was basically equivalent to minus sine of the item in question. And sine of something plus pi over 2, that's going to be cos of the thing that I want to talk about, right? So that's useful. Okay, and then I want to go over here. Now I notice that cos alpha sine alpha is still this point we're considering. This point up here, it's now going to have coordinates cos of beta plus pi over 2 and sine beta plus pi over 2. But I want to just do the same thing. Instead of writing the coordinates of the pi over 2 in them, I'm just going to use the identity we discussed 2 videos ago now. I'm going to write this as minus sine of beta, and this one as cos of beta. Okay, and then using the same methodology as I did with the blue line, we can compare the geometrical distance of the green line, and we can also get the identity out for sine. We can prove, in fact, that sine of alpha plus beta, as we know, is going to be sine of alpha cos of beta plus cos of alpha sine of beta. Okay, so that's a really nice proof of this result. Much faster than drawing a big geometrical mess. Let me know what you think in the comments. If this is useful, if there's anything more I could elaborate on here, do let me know. It's quite difficult to get this concept across in a video. I think maybe I moved a bit too fast in some areas, but let me know what you think. If you're having a good time watching these trigonometry videos, be sure to like and subscribe. I'll keep them going. I'll take requests, whatever. Just trying to get the mouse out there. Cheers.